That was exciting. 85 bucks one way, 85 bucks the other way. Cost me about 300 bucks to get to Victoria and back with gas. But flying is twice that much. Okay, I'm just going to write this. Let me see if you recognize it. Anything yet? Ooh. Whole's the one that starts with a W. What starts with N? Natural. Whole. Integers. Yeah, okay. That's our number system. This stands for all real numbers, which is the only thing you see in public school, okay, even in grade 12. There are numbers that we call imaginary, okay, but, well, if you put that in your calculator, do you know what happens? Try it. Okay, we're just, not really relevant to what we're doing, but I know I've said this before in grade 10, and maybe you've tried that before. What does that say? Non-real. We want real ones, not non-real. You can do this, but not in high school. Okay? In university, if you take sciences, they'll tell you in the math class that you can do that. Okay? Up until about 200 years ago, it didn't make any sense. And then, the smartest minds on the planet got together and said, you know what? It kind of does make sense. Okay? This is equal to 1i, which stands for imaginary numbers. Okay? I'll admit it, it's even a bit beyond me. Okay? I learned it, I know how to do it. Does it make sense to me? Not really. Okay? But to some people it does. Anyway, all we're talking about is the real numbers, okay? These are all Q standard for something else. And then we had stuff that wasn't Q, okay? This was rational numbers. These are all rational, okay? I can write them as a fraction, okay? And they either terminate or repeat. These are the ones that don't, like this thing is irrational, goes on forever and ever and ever. That's what we taught you in grade 10. This picture was in your workbook that all you guys saw, okay? So this is basically what we're doing. This is set notation. This is a Venn diagram. And this is what's going on the next few days, okay? Probably even longer. When we get to probability, we'll see the same stuff. Okay, so again, I won't write all these down. This is natural numbers, whole numbers, integers. Q, I'll write that because you're like, what the heck does that start with? It's probably Latin or Greek. This is rational numbers, okay? So this or this stands for not Q, okay? Which means not rational. But we have a word for that. We don't say not rational. We say irrational. Okay, that's our number system. Again, what's natural again? It's what we can kind of see and taste and feel and count. Okay? And then later on they said, well, you know what? It makes sense to have nothing. I know I can't count 0 rocks, okay? But it makes sense if I had a rock and then I lost it, I have no rocks. And then they went to integers. Well, you know what? It kind of makes sense to have negatives, okay? What if I owe that other caveman 2 rocks? Okay, well, -2, that's what it means. Okay, And then Q stands for, these are all rational. Okay, they all terminate. But we also have numbers like a third that repeats. That's still a rational number. It goes on and on and on. Okay? So we kind of expect you to kind of know this. Okay? But for what our purposes is, we can say n, that's like a sideways U. That says natural is contained within whole numbers. Okay? Or, in this language, in this chapter, we're going to say the set of natural numbers is contained within the set of whole numbers, right? Because all of these numbers are here. The only difference between natural and whole is whole has a 0. That's it. Okay? In this language, they like to use the word elements. I know you're thinking chemistry, but they also like to use the word math. Elements of naturals are a subset of whole numbers. Okay? So this is a funny squiggly sideways U. Okay, that's what that says in math. N is a subset of W. Okay? Or all the elements of natural numbers are contained within the elements of whole numbers. Okay? It's just some new lingo you got to be familiar with. And there's a word for this Q prime too. Q is a, what they call, complement of Q. Okay? Which means it's not Q. So either a number is rational or it's irrational. That's it. If it's Q, and you know why they didn't start that with R for rational, because we already have an R, right? So they had to come up with a different letter. Okay? It's either rational or it's not. It's a complement. Okay? New lingo. So let's give you another example. How about the set of digits? How many digits do we have in our math language? And here's how we write the set. We have 0, 1, 2, up to 9. Okay? Yeah, D for digits. Is there any others? Can we make every number you can think of out of these 10 digits? Yeah, that's what we have. It's called a base 10 system. Okay? We could have come up with a base 8 system. I remember doing that in grade 7. I don't know if that was normal curriculum then or not, but our teacher said, hey, let's reinvent a new number system. We're going to go up to 8. And we did it. Okay? This is kind of what we got, right? And I bet you it's based because, you know, look at these little appendages we have, right? You got 10 of them. That's probably where it came from. Okay? This is called, more lingo, what we call the universal set. Okay? Anytime we're giving you an example, and there's some in the book that are good, you should read those too, because I can't give you 12 examples. We'll be here for 2 hours. Okay? Whatever they give you is called the universal set. That's what we start with. Okay, in this, we're going to have an even set of digits. You all know what that means, right? I'm going to call that E for even set. Use my squiggly brackets. Now, is 0 even or odd? we take that to be even, because one definition says, can you divide 2 into it? Okay, and have a nice number. Yes, you can, because it's 0. I'm not going to argue that point, but that's taken as even, okay? Just trust me. All right, so that's our evens. You see any other evens in my universal set of digits? Or is that it? Is that it, Sean? Yeah, okay. That's it. So the rest are what we call, what? Not even, odd, yeah. Yes, thank you. I didn't do that on purpose. Okay, 2, 4, 6, 8, yeah, okay. That's it. All right, so E is contained within D. All the elements of evens are contained within the elements of the total universal set of digits, right? That's a lot of words, isn't it? Okay, does this make sense? All of these are in here, just like all the naturals were in the whole. And by the way, I could have done this like this too, right? Is whole contained within something else? Yeah, all the integers, right? Which are contained within, there's another circle here, Q, right? Those are all subsets of one another. I can just write it as a big long train like that. Okay? So instead of writing odd, I'm going to write it like that. That says not even, which means odd. Okay? Are these also contained within all the digits? Yes, it is. So that makes sense, right? So let's put just a little words with this. Even is a subset of D, and not even, which I could also write as another different subset, but I want to write the complement is also a subset of D. Okay, so if I want to draw this as a little Venn diagram, I'm going to do this. This is my universal set, D. Within there, I have a little subset. Doesn't have to be a circle. You can make an oval, whatever kind of fits. It could be another square too, right? Doesn't really matter. And this is what I call even, which contains these numbers. And then outside of the evens, I have odds, which were, well, not 0, 1, 3, 5, 7, and 9. Okay? So is there anything missing? No, that should be it. So this is a picture of everything. This is the universal set. It's got evens, it's got not evens, and yeah, I could have made another circle and called it odds instead. Okay? So because it is not possible for a digit to be odd and even at the same time, we know this. Okay, but we got some new terminology to explain it. We say these are disjoint. Okay? Gotta know what the word means. Now, because this is English, we got another way to kind of say the same thing. And again, if you take this stuff in some higher level courses, maybe this would have a little difference. but I think for our purposes it's okay. Mutually exclusive. Have you heard that term before? Because that's used in other places too, right? Mutually exclusive. Disjoint. You can't be odd and even at the same time. Banana. If I wanted to categorize that with some other stuff I go shopping to at the store, right? I might put it in a group called fruits, okay? And other stuff in the produce section would be vegetables. Well, is it possible for a banana or anything to be a fruit and a vegetable? They're mutually exclusive. They're disjoint, okay? And there's some examples in the book that have that. There's tons of other examples, right? That is a fruit, which means it's not a vegetable. I know, most people do, because it tastes like it. Usually fruits taste better, but that's not the reasoning, right? And again, I'm not here to argue whether it should be or shouldn't be. Remember, Pluto was a planet. How many hundreds of years did we exist just happily and with it being a planet? And then the more we learn about planets and other things, which, by the way, they just recently found like whole new galaxies with hundreds and hundreds of planets which could support life, okay? The more they come to the conclusion, you know what, that doesn't really make sense. We're going to change the rules now. We're going to, because we have a better understanding of how the world works, it doesn't make sense to call it a planet. It's not big enough. It doesn't do this. There's about 6, 7 different reasons they came to, okay? And like I say, they talk about this for years and years and years and have discussions and meetings, and finally, okay, they all kind of agree, let's have a vote. Pluto's not a planet. It's a planetoid, okay? So, things change. Okay, what else do I want to say? It's either even or odd. I said it, I won't write it down. Okay, the evens and the odds make up the whole universal set of digits. It's just an example, right? I could have given you the one with fruit, but it's in the book, so I recommend you look at it too. Okay? Let's look at number of digits, which we write like this. Let's make that clearly a D. That says the number of digits. It kind of looks like function notation, doesn't it? How many are there total for the universal set? I said it. How many are there, Ellie? How many digits are there? Yeah. Okay, because you add 0. There's 9 and then add 0. There is 10. How many evens are there? Well, 0, 2, 4, 6, 8, there's 5, right? How many not evens? How many odds? Well, I got them right here. 1, 3, 5, 7, 9. There's also 5. How do I get to the number of digits from the number of even and the number of not even? You see some simple math here? How do I get to 10 from 5 and 5? I add them. Okay, so that makes a little formula. Because the universal set of digits odds and evens and no others, that makes the complete universal set, right? So I can say N of D is number of evens and its complements, and that will work for anything where they have disjoint sets that make up the complete universal set. Okay, so that's in the book too. Remember that nice handy green page, a summary page before the questions you do. Okay, it's in there. There's also another one. I'll give that one to you tomorrow. Okay, last kind of strange terminology I'll give you. There's my squiggly brackets. Is there anything in there? No. That means empty set. There's other ways to write it. Okay, I'm not going to write them all down. They got other different ways. Okay, like that. Okay, but I think that's fine. So, pi. Our set before, or this set, okay, it was in the first set. That's an irrational number. That was contained within my universal set, right? That was all real numbers, rational or irrational. So that was a part of it. But here, is that a digit? Is it even or odd? It's neither. It's an irrational number, right? This can only be whole numbers. Okay? So this is not odd. It's not odd or even. So it's not a subset of my universal set D, which was digits. Okay? So that's an empty set. It's not included, but using their terminology, that's what we say. Okay? That's about all I think you need to hear. Okay? Complete 180 from the stuff we've been doing, right? Okay, we got to get kind of familiar with doing this kind of stuff. And like I say, it's logic. A lot of it's kind of common sense, but it can get tricky. Okay? So 1 to 3 and number 5. Tomorrow we'll do different other questions in the same unit.